In the last video, we looked at the graph y equals 2 to the power of x. When you try and plot it, it will look something like this. And this point here is 1. And as you head towards minus infinity, don't worry about this minus infinity too much. But as you head really far to the left, the line tends to 0. It heads towards 0, but it will never reach 0. It's slightly hovering above 0. Okay, and as it tends towards positive infinity, and again, think of infinity as a really big number, really high number. As you head towards infinity here, this line here, it will get bigger and bigger and bigger. Okay. Now in this video here, we are going to investigate what happens when you have y equals, let's say, earlier it was this 2 to the power of x. What happens if this number here is less than 1? Is less than 1. Let's say 0.8 to the power of x. You see, when you have a number bigger than 1, let's just look at 2. When you look at this line here, as you head towards positive infinity, this thing here goes up and up and up, because, well, if you get 2 times 2, and then you times 2, and then you times 2, it gets bigger and bigger and bigger each time. Now, in this case here, oops, hang on, sorry. In this case here, hang on, bear with me. Let me just adjust this. Okay, in this case here, when this number here is 2, it gets bigger and bigger and bigger at each stage. Here, because it's a number that's less than 1, it gets, as you head towards in positive infinity, it gets smaller and smaller and smaller. So look at this here. If you look at this, let's say y equals 0.8, okay, to the power of x. Now, if you have 0.8 times 0.8, the overall answer here will get smaller. It's actually smaller than 0.8, because look at this here. I don't know if you can remember, but in the percentages chapter, we did something like this. Let's say this is your whole of something. So this is your whole of something here, 0.8. Now, if you times 0.8 again, so if you times 0.8 here, what this really means is this is your whole of something. This is the whole of something. And when you times 0.8, it's similar to you saying, get 80% of this whole thing here. Get 80% of this whole thing here. So it's going to get smaller. Okay, if you don't understand this percent thing, don't worry about it too much. Just know that this is your whole of something. And when you times 0.8 here, you're going to get, hang on, if you times this 0.8 here, if you get this times this thing here, you're going to get the new thing. Now, this new thing here will be smaller than this 0.8. So 0.8 here, get this times this. This will be 0.64. Now, 0.64 is actually smaller than 0.80 in effect here. So can you see 0.64 is actually smaller than 0.80. Now, if you get 0.8 times 0.8, by the way, this bit here is this bubble here. Now let's say you get this bit here, and then you times 0.8 again. So you times 0.8 again. So it will look like this. Hang on. Let me get rid of this. Okay, hang on. So this thing here, this bubble here is actually 0.64. Okay. Now, if you happen to times 0.8 again, so 0.8 here. Now, if you get this times 0.8 again here, it's like you saying, I'm going to get 80% of this. So it's going to get smaller. Well, my point is, if you get this times 1, it will remain at this level. Now, if you get this times 0.8, it's going to get smaller. So this thing here will be, hang on, let me get a calculator out. Hang on, calculator. So let's get 0.6, 0.64 times 0.8, 0.8 equals 0.512. Now, can you see that this 0.512 is smaller than this thing here? Okay, so 0.8 times 0.8 times 0.8 here. This thing here is actually this thing here. Okay. Now, suppose you get this thing here, and then you times 0.8 again. Times 0.8 again. So what that means is, hang on, let me just tidy this up. So what this means is that, well, don't forget this 3 times. When you times it 3 times, this bubble here is actually this bubble here. Okay. Now, if you get this times 1, it will remain at the same level. But then because we're multiplying 0.8 again, so it's going to be this times this. And look at this. This new bubble here will be smaller than this. And as you continue, it gets smaller and smaller and smaller. My point is that when we have y equals 2 to the power of x, okay, it looks like this. It looks something like this. Because as x increases in a positive direction, this thing here gets bigger, because when you get 2 times 2 times 2, it gets bigger and bigger each time. Okay. Now, if you look at y equals let's say 0.8, it could be 0.23, as long as it's less than 1. Okay. Now, if you look at this here, as you remember, 0.8 to the power of 0 when x equals 0 is still 1. So you know it cross this thing here when x is 0 is the same as this thing here. Okay, it crosses at 1. Now, but the only difference is that when you increase x in a positive direction here, this thing here gets smaller and smaller each time, because it's, let's say you start at here, you times 0.8 here, this overall thing here is going to get smaller. Now, if you times 0.8 again here, this whole thing here is even smaller. Now, if you times 0.8 again here, it's going to get even smaller. And times 0.8 again here, it's going to get even smaller. So my point here is that this graph will look something like this. It gets smaller and smaller and smaller, and it heads towards 0, but it never gets to 0. Okay, but it turns out that this graph here will look something like this. It looks something like this. Okay, but in this video we are just looking at what happens when x increases in the positive direction. In the next video, we will investigate why this is. What would happen when we increase x in a negative direction? Okay, so hang on. Something that I want to point out. Hang on. Let's say you have 0.8 to the power of x. Now, so 0.8. So this one here would be 1. Okay, and it decreases as x increases here. As you go towards the right. If you keep on getting 0.8 times 0.8 times 0.8 times 0.8, it's going to get smaller and smaller and smaller and smaller. But it doesn't actually get to 0. It just doesn't get to 0. It gets smaller and smaller and smaller. If you keep on doing it, you get 0.00000, and then you have something like this, 1, 2, 7, something like this, and then if you keep on multiplying another 0.8, it's just going to have more zeros here, and then maybe 2, 3, 7, or something like that. It just, as you increase in this direction, it just doesn't get to 0. It heads towards 0, but it doesn't get to 0, and it remains on the positive side. Okay. In the next video, we will investigate what happens when you looking at this thing here. What would happen if you increase? If x heads towards minus infinity, in a minus direction, as you go really far to the left in the minus direction. Okay.